Okay, so 4.3 is parallel and perpendicular equations, and you'll just learn how to write an equation of a line that's parallel to another line, and you will also learn how to do perpendicular ones. So please make sure you copy these down into your notebook. They will help you later. So first of all, parallel, if we don't remember what parallel means, it just means that two or more lines that never intersect. And in equations, it's really easy to tell because parallel lines have the same slope. So for example, if I had something like y equals 2x plus 3, and I had y equals 2x minus 4. So I can tell right away that these are going to be parallel because I'm just comparing the slopes. And if the slopes are the same, they're going to be parallel. Remember, you graph there. Oh, so 1, up 2, right 1. You can also go down 2, left 1, down 2, left 1. So there's my first line. And then the second line, I'm going to go down 4 to start. And then again, up 2, right 1, up 2, right 1, up 2, right 1. And you mostly want to make as many dots as you can until you fall off your graph paper. Mine's pretty large, so I'm going to stop there. So you can see on these two lines that no matter where you count, here we're going up 2 over 1, and it's going to stay equal distance on this one, up 2 over 1, up 2 over 1, and it's going to keep staying that equal distance all the way up. So the next thing you may have to do is to determine which lines are parallel, and literally all you have to do is count the slope. Once you count it, then you can compare it for each line. So I'm going to start with this orangish red, and I'm going to start at this dot here, and I'm going to count how many up. I count up 1, over 1, 2, 3, 4, 5. So for the red, I counted up 1 and left 5. So red's negative 1/5. Then I go to the blue 1, 2, 3, 4. So it's close, but not close enough. So those are actually not parallel. They will eventually cross somewhere. And then the green one, I'm going to start right here, count up 1, over 1, 2, 3, 4, 5. So we can see that the green and the orangish red ended up being the exact same. Alright, the next thing you may have to do is write an equation of a line that is parallel to y equals 2x plus 3, but it has to pass through this point right here. You would just start at this point, this 5, negative 4. So 5, negative 4, right here. And then you would just have to use the slope given. So the slope has to be parallel to this one. It's got to be a 2. So we would just continue to go up 2 over 1, up 2 over 1, up 2 over 1 until we got our line. And you can write this in slope-intercept or point slope. It doesn't really matter. But I can see here that I still don't have a y-intercept. So that might be easier to write that in point slope. But if I had a little bit bigger piece of graph paper, minus, and then I'd have to count all the way down here. And it looks like it's 14. So that's one way. Another way would be to find the slope and then just plug in a given point. So I would probably use point slope for this, but again, you could really use either method you wanted to. We already know the slope because it has to be parallel. So if it has to be parallel, I have to use the same slope as the given. So I'm going to want to make sure that I use a 2 for my m. So I'm going to replace the 2. Then the point it has to cross through is this one. So this has to be the point that I use for my point. So I'm going to have y plus 4, because minus a negative, and then 2 parentheses x minus 5. Go ahead and distribute. 2x minus 10 equals y plus 4. Get rid of the 4, and you can see you get the same answer. Y equals 2x minus 14. So you get it the same way, or the same answer that we got when we graphed it. The third and final way that we can literally get the exact same answer is to use y equals mx plus b, and we already know the slope is 2, so I can go ahead and fill that in. Y equals 2x plus b, and right now I have 3 variables in there. I've got a y to use. We know the slope is 3 variables in there. I've got a y, an x, and a b, and it's impossible to solve for all of those. So what I can do is solve for b, and I can use the point that they told me it had to pass through. So it had to pass through 5, negative 4. So if it had to pass through 5, negative 4, what I can do is I can plug that in for x and that in for y, and it would solve the b. So again, it's just another way. You don't have to do it this way, but if you think that's easiest, and then notice right here, I only have 1 variable. So if I would go everything down, minus 10, and yet again, we get b equals negative 14, and we would just replace y equals, we know the slope is 2 because it has to be identical, minus 14. So again, 3 ways to solve the same problem. All right, so now switching gears, perpendicular lines. First of all, if you forgot what perpendicular lines are, it just simply means that you have 2 lines and they have to cross perfectly at 90-degree angles here. So like a vertical line and a horizontal line, those would be perpendicular. So parallel had to have the exact same. Perpendicular is we have to have what's called opposite reciprocal slopes. So reciprocal, first of all, a reciprocal simply means flip the fraction upside down. So if you have something like the slope is 1/2, to flip it upside down, we would just say 2/1. Or maybe the slope is 3/4, flip it upside down, 4/3. Or maybe the slope is a whole number. Maybe the slope is 5. Well, down. Okay, so that's the reciprocal part of it. But now, for the opposite, it means if it was positive, you're going to make it negative. And if it was negative, you're going to make it positive. So, for example, if this was negative 1/2, opposite reciprocal would be a positive 2/1. If this was a positive 3/4, then the opposite reciprocal, I would make that negative. If this was negative to start, I would make this one positive. So opposite reciprocals, you have to flip it and also change the sign. So you may have to determine if they are parallel, perpendicular. First, figure out what these lines look like. What you could do is simply 2, negative 2. And my line is here. I'm going to go ahead and count that slope to see what my slope is. So I count 1, 2, 3, 4, over to the left 2. So when I simplify that, this top line, the slope is negative 2. Then I'm going to go ahead and draw that line. Okay, so there's my first line. My second line says it passes through 0, negative 1, 0, negative 1.